All right, so let's take a look at the software development methodology. So there have been over the history of software engineering multiple techniques that we have tried out to address the complexity of working with in large teams. First of all, it's useful to understand the various stakeholders or the various players in the process. So the two large, the two of the more important groups of that are in the software engineering process is the client, the person who comes to you with a problem, that comes to you with the investment, right? That says, hey, I need this solved, right? And I need it by the end of the year or in the next couple of years, and this is the budget that I have, right? So that's one chunk, one big part of the constituents of a project, right? That they control usually, the budget. They control the time that they need this by, and the feature set that they're looking for. And you have the tech team, right? That they control certain other things, right? Where they can control the actual folks that are going to be building this, the process by which they're going to be developing this, and also the technology stack that they might be using. So they have the different control knobs that they're responsible for. Within the teams, they because they're going to be dealing with multiple teams, an organization made up of multiple teams, they're going to have to make an effort at dealing with the messiness of working with teams, right? They're going to have to deal with working in their communication, and that we all agree on what it is that we're doing, that on how much level of documentation that we're creating, depending on what process you're using. This is going to be heavy on documentation or very light on documentation, right? Usually in the AGILE, the type of process is very light on documentation. You only document enough to understand and make sure that we all agree that this is what we're building, right? We don't document per documentation per se, right? Document doesn't have any value on its own. It's only valuable to the extent that it explains what is it that we are agreeing to build. Also on the tooling that we're going to be using, the process, the name, the file conventions, the structure, the architecture that we're going to, and how is it that we're going to, bring folks on board and hand off, our work to someone else, which we're going to try it out in this semester, right? Where the teams are going to be focused on a particular feature, but then every so many sprints, we're going to have one team take over the work of some other team, right? Just to experiment what it means to hand off work from one team to another. It's going to be very, very chaotic, right? We're going to have teams going back and forth asking for help, right? Impacting the schedule of each one of the teams, right? So that's going to be tough. So we're going to try that out. Different aspects that influence the project, obviously the complexity, and there's no way that any one person knows the entire complexity of the project. The knowledge is out there, spread over large amounts of folks, and also the typical that you're not going to start from scratch. In our project, we are going to start from scratch at the beginning, right? But as we progress, we're going to switch the teams so that you'll have a taste at working on somebody else's code, which is everybody hates. Everybody hates working on somebody else's code, right? So we'll experiment that. Some of the key elements of any of the processes that we're going to be looking at, they consider whether what we're going to be working on or building, is it even feasible? Can it even be solved? Right? Is an NP complex that we cannot be solved? Right? Are the specifications there that formally describe what we're going to be building? Formalizing what the architecture and the design is. What the actual development process, and can we validate whether we have successfully achieved a particular requirement? Are there any objective measures that can say that yes, indeed, we have met a requirement, and how is it going to be deployed and maintained at some point? All right. So some of the processes, a little bit of history of the processes. Very early on, it was very hectic. Right, in the 1950s, there was no process. Right, we just worked on something until the client said they were happy. Right? There was no notion that there were different levels of concerns. Everybody did everything. Right? Everybody worked on the user interface if there was any. Everybody worked on the data storage. Everybody worked on the event handling. There was no distinction that there were different skills that were needed for different aspects of the application. Today, we have identified different separations of concerns, right? When you build a user interface, there's a whole set of concerns on what it is of making something look pretty, right? And working on themes and styling and human-computer interaction. There's a whole body of concerns of how to create a user interface, right? And a whole set of skills that go along with that. But when you're working on the back end, the database, there's a whole set of other concerns, right? On the data modeling, whether it's a normalized or denormalized data model, right? Where you have several one-to-manys or many-to-many relationships and so on and so forth. That's a complete different set of concerns. Yes, and all the optimization of certain queries and indexing, and that is a complete different set of skills. Yes. And in the middle tier, there's a whole different other concern. So back then, there was no such thing, right? But today, we have identified these complexities. We have worked on so many projects that we have identified these patterns, right? And different design patterns used for dealing with these different concerns. Over the years, we have identified certain common set of activities that is common across all projects. We have identified that there's a first set of, at the inception of a project, there's going to be a lot of meetings, a lot of interviews, a lot of meetings across multiple stakeholders across the organization. A lot of folks doing a lot of brainstorming, filling out a lot of forms, looking at how people are working currently, capturing all the pain points of a system that already is in place. Looking at all the logs, a lot of the failures of the old system, and capturing everything of what was that we're trying to solve, and then planning. Trying to identify what are we going to do first. What should we tackle first? We don't have infinite time. We don't have infinite money. We don't have infinite resources. We have to identify what do we do first. What's the most important thing? So that's another aspect of software engineering. And then we have to find some formal way of documenting or representing this symbolically, with class diagrams and sequence diagrams and activity diagrams and whatnot, and doing the architecture and what is it that we're going to be building. And then actually building this. And at some point, this needs to be deployed, maintained, and servers started over and then maintained over time. Now, in the waterfall, way back in the 70s, the model was that you go through this once, right? Where you first meet with a client, the client gives you all this information, you disappear for 2 years, right? And when you come back a little later, you give a final result, and all happy. This is exactly what you asked me to do, and indeed this is what I'm delivering. The client looks at it and says, yes, I know that's exactly what I asked you to do, but I hate it. And says, well, why is that? Why is it that I built exactly what you asked me to do, but you end up you end up coming up with saying, what is the difference between what you asked me, and then you're not wanting exactly what I gave you? And this is a comic that tries to capture that. So the problem is that projects rarely have a nice sequential direction. It's more like a tree, right? Like a decision tree where you get deeper and deeper and deeper, and then you have decisions that make you go one way or another as different factors change over time. And the customers usually are not involved in any one of those decisions, right? And so oftentimes, where you started and where you wanted to end up, you actually end up somewhere else, right? Because of all sorts of little decisions that you had to go through, but not involving the customers, right? You never had the feedback to kind of put you back in the direction where you wanted to, when you actually wanted to arrive. So a lot of these decisions can take you into disastrous results. So trying to solve this, a lot of folks, really, really smart folks, have thought about, how do we fix this? Barry Boehm is somewhat worked a lot on this idea, and the way he thought about it, it says, well, what if we work on really small pieces of this small versions of something, and we incrementally bite off of, chew something bigger over and over time, and then we apply these same steps of design and planning and requirement implementation and testing, over and over, and we can deal with bigger versions of the same problem, right? Until we then give you the final results. He also did a lot of statistical analysis on the cost, of making an error at different portions or solving, identifying a problem over time. And the longer you took to solve a particular problem, the higher the cost of the overall project. So he advocated at making sure that you really understood what it is that you were building before making any larger investment and getting into towards the final solution. So over time, folks identify the need to not do the one shot, but instead breaking it up into smaller chunks, right? And applying the overall process of communication, planning, modeling, construction, deploying over and over time, for different features and provide different increments that added an incremental value to the project. So the incremental model, the first increment might provide a minimum, an MVP product where you might have the core functionality of the application and then add new features over time. Where it applied this over and over, and at the end of each iteration, it provided an incremental value to the product. Another idea that became very in vogue was prototyping, right? So instead of because the mistakes, trying to solve this, right, to identify these problems earlier, folks that says, well, let's not try and build something right out of the bat, especially if something is fairly complex and we don't know, right, how hard this is going to be or the bad decisions that we might make. So it says, let's prototype it with something that's very cheap, right, perhaps enough to give us confidence that we're going to be successful. So there's two types of prototyping, the horizontal prototype and vertical prototypes. That can be applied at different layers of the application. Usually, complex applications have multiple layers, where the top layer might be the user interface, and the bottom layer might be data storage or and whatnot, right? A middle tier or services or business logic. So for instance, at the top layer, horizontal prototyping works really well, where you might create a very simple, just on the board or on Photoshop or maybe on PowerPoint slides, create a very cheap version of a user interface that you can quickly put in front of the client. They can click away and see and give you feedback on whether they like it or not, right? And it's very cheap. It's something you can put together real quick with no real implementation. And this allows you to take feedback, move things around real quick, lay it out differently to see if, and gather feedback from the user really early on, right? As opposed to building something very expensive and then not being exactly what they wanted. Same thing with vertical prototyping. Looks at prototyping something across multiple layers, right? This is especially useful when you're dealing with new technology or you don't says, hey, I heard we're using Angular, or we're using React, or we're using JPA. I don't know what that is, right? And oftentimes it's useful to create some really small throwaway example, right? That gives you confidence that says, oh, I understand this. I get it now, right? Now I can now use this stack or this technique or this new technology and understand all the different layers, right? So you for instance, we have already started some of that prototyping where we're kind of in the middle tier here, right? We created a couple of controllers, a couple of data models, right? That was a little bit of horizontal prototyping, right? A service, a model, right? A couple other things that we might put in there, all in the middle tier, right? In the middle tier, you put business, you put models, you put services. That would go over here. Some prototyping on the top layer might be creating a couple of pages, right? Some really simple HTML pages. And maybe at the bottom, you're creating a very simple database, a schema, a really simple hello world schema, and then understanding how these talk to one another, right? Let's create a little, really tiny, small hello world, React component at the top that sends some HTTP request to some really simple hello world middle tier that then writes to a database down into some row and then goes back and forth and says, oh, I get it. I understand this enough. This is especially useful for managing risks, right? If you identify a particular risk factor, it's a good idea to prototype it. Prototype it to minimize the risk and says, okay, at least I know what I'm getting into. You create a proof of concept enough to give you confidence. Now, oftentimes, developers might fall into the trap of using a prototype and try to build around it an application. So you should try and avoid the temptation, right? Oftentimes, your prototype is so good, right, that you've spent so much time on it. You're really good at prototyping HTML. You put it in front of the client, and the client gets the wrong expectation that you're done, right? They say, oh, you're almost done. It's almost working, right? So you have to manage those expectations with folks, and says, oh, well, you just add a middle tier behind this and some couple of tables, you're done, right? So careful. Usually these prototypes are meant to be throwaway prototypes, right? It's enough to give you confidence. You throw them away, and then you actually go and build the real thing, right? So you be careful with prototyping. So spiral model is a little bit the same idea as we mentioned earlier, where you deal with ever increasing bigger chunks of the project. Unified process in the 80s, the late 90s, took on several ideas from different processes. The prototyping process and the iterative process, taking some of the ideas from previous models and combining them into a unified process, right? Where it took the best features of multiple processes and combined them, emphasizes on architecture. Here's examples of using the different layers of the and then repeating over and over onto multiple iterations as you iterate over the results of delivering the product. And at each increment, you provide some software increment that gets deployed into production. All right, I'm not going to go over some of these. So AGILE. So AGILE is the current, it's pretty much the current standard where you're probably going to be in most of industry that the process that's being used mostly in industry, and the name tries to suggest a distinct way of thinking, right? That we're gonna leave behind, the very heavy, slow to react methodologies of the past. Those are the legacy processes. Instead, we're going to embrace chaos, right? We know we're going to accept the fact that working in large project is chaotic. That's fine. It's a reality of software engineering. We're going to embrace it, right? How can we better deal with this, right? So AGILE has certain aspects about the software development process, and one of them is that instead of being heavy on the documentation, right? Legacy processes were really heavy on documentation. You had let's draw all the diagrams and all the data schemas and all the sequence diagrams and the activity diagrams, even before we write the first line of code. Okay? In AGILE, it says, okay, well, documentation is important, obviously, but it has its place, right, and time, only insofar that it improves the understanding of what it is that we're building, right? But we're not going to document per documentation's sake, right? There's no value in documentation, right? Whereas because the documentation might be stale. I documented something, but that's not actually what we're going to be building. Then why do I even document it? So we're going to document just enough that if we don't understand each other, well, let's go to the board. Let's draw it out, right? We'll draw a couple of diagrams. We'll put a couple of arrows. Once we understand that, that's enough. We'll take a snapshot with our phones. We'll add the image to the ticket, and that's the document, all the documentation that we need. That's it. Okay. There's also a lot of focus on the working software. The working software is the documentation. The software should be self-documenting, right? My functions, my methods should have a name, right, that is so self-explanatory that what else do you need to know, right? The name of the function says it all, right? The arguments say it all. The variable names that I choose say everything. Okay, my algorithms are so well structured that it is obvious what it's doing. I don't need to do any pseudocode or even comments. Comments are irrelevant, right? If I need to comment, it's because it's too complex. I should make it even simpler so that it's just self-explanatory, right? So a lot of the focus is on working software. Also, a lot of focuses on the interaction of developers. So as opposed to the process, right, of creating tickets and knowing the statuses of tickets, and instead, let's just all sit in the same table. Let's work together. Right? Let's do peer programming. Let's I committed this into this branch. Merge it into your branch. Try it out. Test it. Right? And you look over my shoulder, and we criticize each other, and we work together to improve the quality of the code, as opposed to processes and tools. So a lot of focus on customer collaboration instead of waiting months before knowing whether the client likes what we're doing. Let's involve them in the process, right? Every week or every other week, let's give them a demo, right? So that we can get feedback, and they can quickly tell us what we did right, what we did wrong. Maybe they'll add a couple more features. They'll change a couple things here and there. But at least we, instead of starting A and trying to get to B, and as we progress, we kind of wander off, right? As we include them in these meetings, the client will put us back in the right direction, right? Will give us feedback. So a lot of customer collaboration and keep them up to date right away, right? So responding to change instead of having be adverse to change is responding to change, right? So a lot of folks, especially on large corporations, larger corporations tend to be somewhat adverse at Agile. Some of the folks have been around for quite a while. They're comfortable with Waterfall, and it's very well defined. And they see Agile as a little bit too chaotic. What is this? It's just hacking. Just hack at it it's kind of going back to the 1950s, right? You just iterate until you're happy. It's kind of going backwards, but not quite, right? So the idea is that we're going to be mindful of changes. We know they're coming, right? We're going to try and notice them early on and immediately make a decision on that change, right? Is this going to affect our schedule? Are we going to accept it? We're all going to agree that if we're going to accept this new change, it's going to affect our delivery. Is that okay? And then we all, as mature adults, right? We all agree that that's what we're going to do. And so it's not going to be nobody's going to be surprised at the end, right? Of that, because everybody's well communicated. It's very well, and we can quickly reorient resources to deal with this new challenges. So basically, what we've seen over time is that we've taken the idea early on from Waterfall, and basically what we've been doing is just squishing the time frame. We've been squishing the time frame, but applying the same principles, right? Where we have the iterative. These are wrong. This is the agile over here. This is the agile where basically we squeeze the time, instead of being months or years of going once through the entire process, is instead applying it down to maybe weeks, right, or days, where we iterate and apply the same 5 principles over and over, including the product owner, the client at the end of each phase, to get a feedback that then feeds into the next iteration. Okay, so basically that's agile.